All right, welcome back. I hope you're having an amazing time so far. Our next speaker is Hanya Young. He is a VP Quantitative Analytics Specialist at Wells Fargo. Please join me in welcoming him to our virtual stage.
Thank you and good afternoon, everyone. This is Hanya Yang from Wells Fargo's Model Risk Management. And currently, I'm leading the model validation for the natural language processing models, meanwhile researching and developing tools and methodologies for the natural language models. It's my great pleasure here today at the AI4 conference, and I would like to share a work we recently developed to systematically assess the natural language model's robustness. And here we go. So natural language processing models is a very hot area in the AI domain. And nowadays, it has been using widely in the financial institutions, and its usage is growing and very rapidly in recent years. And just give a few examples that we're being using in the financial institution. For example, the chatbot that can be used to support the customer service, and the email classifiers to understand the customer's needs and inquiries. And meanwhile, some surveillance models to monitor regulated employees' electronic communications, which is required by the regulators. And nowadays, the natural language models rely heavily on the AI techniques, and the benefits are very clear. So such models usually has scalability in handle very large and complicated text inputs, and meanwhile generate a prediction outcome in a very short time. And also such models usually achieve very good model performance. And typically a natural language model's development process contains two steps. The first step is vectorization. So it somehow converts the input text into the structured features, because the input text usually have an unstructured way. So we will use like different schemes, for example, embeddings or other feature extraction ways to convert such text into the structured features. And based on such structured features, we will apply the model framework. Such model framework will take the structured features as input and predict the outputs. And the model framework can be like, typically will be the machine learning and the neural network algorithms such as CNN, LSTM, or like XGBoost for the classifications. And besides the benefits, as commonly known for many AI models and NLP models is not an exception, is like such model can be vulnerable against the small changes as well. So this means like if we apply a little bit and change or like in the input text, and the output results will be significantly different. And such vulnerability actually exposes the financial institutions into many critical risks. And I will give some examples. So for the chatbot, it will impact customers' satisfaction. And another example is about the toxic content detection, or like the surveillance model we just introduced. So because this is required by the regulators, and if we are not able to produce a robust model, and the model will kind of like be vulnerable to such situations, it will raise the compliance and the regulatory concerns from our regulators. And so in the financial institutions, the model risk management perspective, knowing a NLP model's robustness is very, very important. And it allows us to identify and understand the model's robustness. And if there is any problem exists, allows us to mitigate the model's vulnerability before implementing it for the production use. And the next question is how we assess or understand the model's robustness. And I will just give a very intuitive example. So here, the original text is this process is ridiculous. And the model predicts this sentence as a complaint and assigns a very high score. And however, if we accidentally insert a space in the word ridiculous, and the model may probably no longer able to correctly predict it. And in this example, the model instead will predict it as a non-complaint and with a very low score. And this will just give us the hint like we can utilize the adversarial text to formulate our test, and such test can reveal the vulnerability of the natural language models, thus provide protection against the model's misuse and security breach. And so for our work as a model risk management side, we develop a systematic process for such text generation and for the robustness assessment. And the overall process contains two parts. The first part will generate the adversarial text. So everything essentially we need is just the input testing data. So as long as we have the input testing and the original testing data, and we are able to generate the corresponding adversarial text. And here we want to mention, like, if optionally, we know the target model, and it will allow us to generate the adversarial text more efficiently. And after the adversarial texts are generated and move to the second part, we are going to measure the robustness or assess the robustness. And everything we need is the original text, which was provided in the testing data, and the adversarial text we just generated. And for each piece of the text, it can be scored by the testing model. And the testing model, they will be generate the two different output for the original text and adversarial text separately. And we just compare the difference, and from the difference help us to understand how the testing model is robust to such adversarial attacks. And we will give a little bit more highlights about this entire evaluation process. So first, we automate and standardize the entire NLP model robustness evaluation process. So remember, like when we are reviewing a lot of natural language models that are utilized in the bank. So we would like to automate this process and apply the consistent criteria across different models. And the second thing is our evaluation process is able to accommodate a variety of model pipelines. So again, as a model management, model risk management, we do not develop the natural language model directly. So the model developers, which usually come from another team, they have the flexibility to choose the best or most appropriate model framework. So it means like at our end, our evaluation process should handle different model pipelines or frameworks, either like they use different vectorization scheme or they use different model like framework, CNN or STM. It allows our evaluation process to accommodate all of such procedures. And typically, I want to mention is like as financial institutions, besides like we ourselves develop the models, we sometimes purchase the model from the third-party vendors, and it brings even difficulty because for such models, we don't really own this model. And whenever we need to make the prediction, we will send the data to the vendor. And the vendors, they will run and prediction the data in their environment completely. And they only return the results back to us. So means like such vendor hosted model is totally a black box model for us. So we know nothing besides the input and output. And our evaluation process is also able to accommodate such vendor hosted black box models. And the next, this evaluation process can be customized for different user scenarios. And this is very important. And back to the two examples I just talked in the last page. So we want to create the situations because we do not want to apply or formulate our test, which will be unrealistic. We really want to assess the model's performance under very untypical or very possible scenarios. And for the two examples, like for the chatbot, if imagine I'm the customer, I just want to type in the question and looking for the assistance from the chatbot. So I will, but it's likely like I may add some typos, I may misspell some words, or like I may rephrase the same sentence in another way. And we are looking for like the chatbot is able to handle the different such variations. And another scenario will be in the surveillance model. So surveillance model is usually used to monitor certain employees like communications. And suppose I'm such an employee and I really want to send some, and I have to send some non-compliance message to someone else. And Meanwhile, I understand that there is such a monitoring model in place to monitor my communications. So definitely, I will not just send the original text. I try to, or like I will intentionally to manipulate this text, and with the purpose that my recipient, that human will still correctly understand what I want to say. But meanwhile, I try to evade the monitoring model's detection, try to fool this model. So this will be another scenario, like it's possible, like for certain model and its purpose and use, like there will be some scenario like people will intentionally to create some adversarial situations. So our evaluation process is able to be customized to for different use scenarios, and to that allows us to have the assessment in the proper way. And also this process will assess a variety of the adversarial strengths. So generally we know like the stronger the adversarial and the much significant of the impact regarding the robustness, but some of the strengths may not be realistic. So we will assess the situation under different adversarial levels. And also based on the inputs, this process will automatically assign the optimal adversarial attack strategies. So here, by saying the input, we mean like what's the input testing data, and what will be the, if optionally we have the input a model or like some additional information. This process can utilize such information and to design a optimal way to create the adversarial attack. And also this process is optimized to in terms of the computation time. And the next, we will talk about the two parts of this evaluation process. And the first part is the adversarial text generation. And we are just introduce some typical generation strategies. So this is not everything included in the current evaluation process, but just some typical strategies we want to share. And the first is about what will be the typical actions we will use to generate the adversarial text. And some examples include a perturb, which is usually to mimic the typical misspelling and typos in the daily communication. And also we may replace a word by its synonym or like a similar word or phrase or negation. And also another situation is because we normally know that stop words, they do not carry the actual meaning. So that means like we can try to insert some additional stop words or delete some of the stop words, and to assess whether it will impact the model's prediction. And here I'm giving an example. The original text is he's disappointed with this product. And so we will pick the word disappointed. And the first action, we may just delete one letter from this text and called disappointed. And also we can replace disappointed by similar words like discouraged, or like by utilizing the negation, like he's not satisfied with this product. Or we can just delete the word is here. And all of this text actually a human can still correctly understand what does this mean, but we want to assess whether the model is still able to correctly understand it. And the next strategy we want to discuss here is about how we can create the meaningful adversarial text. So again, this evaluation process is can be used to evaluate the model's robustness in the real applications. So it means like we have to make sure the adversarial text we generate will be realistic. We are not generate a very weird adversarial text, which are unlikely to happen in the reality. So this is a challenge for us. And here, remember, like the actually adversarial attack is a general concept, and it has been successfully applied in image processing a while ago. But the difference here is that in the image, usually the data can be considered as continuous. But however, in the language space, it will somehow it will be in the discrete space. So it gives additional challenges here, like how we can make sure like the adversarial examples we created are meaningful. And some of the approaches we are taking is we will apply some constraint on the attacking words, so the words we are going to replace. And such constraint may include a POS tag or like a polarity, or that means like we will have a pool of candidate words, and by utilizing such a constraint, we are picking the most appropriate word and to replace the original word. And also we can utilize some establish the dictionaries, for example, some known synonyms and antonyms and phrases. And by utilizing such dictionaries, we are able to also generate the meaningful adversarial text. And another topic is about how to select the word for the efficient attack. So again, like if we look at this example, he's disappointed with this product, and some of the words will be more important to determine the entire sentence meaning than some other words. And in this text, disappointed generally will be important to because it's showing the sentiment of this sentence. And so naturally, if we are able to pick in this word and to apply some changes, then we will usually create some very efficient attack. But the problem is how we can choose this word rather than some other word. And we give a couple options. The first is like if we know the vectorization scheme and we know the model framework, then we are able to calculate the weight or gradient or some other metrics that can be represented the models in each word's importance. And so a more important word, they will have the priority to be attacked. And if we have somehow know some prior knowledge on the model, for example, we already understand a list of the important word, and we can utilize such knowledge and to apply the adversarial attack as well. But at least if we know nothing beyond just the model's input and output, we will still have a way and we quite leave one out. And the idea is very simple. So means like for each of the text, every time we just delete one of the word and we rescore this sentence. And if a word, if by removing it will cause the significant change in the output score, then this word will be considered as more important. And this is a way also can be used to help us to determine which word is more important. Although it's computationally expensive, but at least it provides a way to do that. And so by using the efficient attacks, so we can mimic like some intentional scenario, which I just mentioned about the surveillance model, like people may intentionally manipulate the word. So definitely, he or she intentionally will be manipulate the most important word. So some other examples, like if we are just doing the attack randomly, so we will not necessarily to select the disappointed, but we may select the word, pick the word product and apply some change. And also the strengths we can sometimes characterize by how many words are changed in this sentence. And we will change more than one word. And we can use the percentage or number of words to represent the strengths. And these are some typical strategies we use for our text generation. And we have more things here, but after the adversarial texts are generated, and the next question is how we can measure the robustness. And here we'll offer a couple of options. The first way is very intuitive, like we will compare the model's prediction outcome before and after the attack. So here is the example. So we have the same testing model, and we have the original text, and correspondingly, we have the adversarial text. And for both texts, they will be scored by this model. And it will give the score for both original text and adversarial text. And we can just calculate the difference of this score. And this score can directly measure the model's sensitivity to the adversarial attacks. And but remember, like in the model risk management, and particularly for the financial institution, we may have more concern if the model's performance will be impacted. So if only changing the model's outcome, not necessary to decay the model's performance. So for that consideration, we may instead to use the model performance metrics rather than the output score. So similarly, for the original and the adversarial text, we can have the corresponding metric as well, and we can calculate the difference in the metric. And here the metric can be like any metric, appropriate metric to representing models performance, such as accuracy rate or AUC KS score or something to represent the model's performance. And we will compare the difference. And by doing in this way, actually, we are measuring how the adversarial attacks impact the model's performance. And once such vulnerability is identified. And the next question might be how we can assess the severity of such a weakness. And in this way, if we are able to obtain a second benchmark model, then we can compare the sensitivity or like the change against the benchmark model's change, and it will give us a way to how to assess the severity of this weakness. And this will be some overview of the entire evaluation process. And due to the time, I'm skip this example part, but everything has already been covered in the previous slides. And next, we will introduce two case studies. And the first case study is how we utilize this evaluation process to assess the model's robustness. So actually, this evaluation process has already been successfully applied in a variety of natural language models in our bank for the robustness assessment. And just give one example is like one model is found to be vulnerable, and even the adversarial attacks are slight and generated without intention. And here is an example, like for each of the individual texts, we only change one word, and even the attack is randomly, and about 18% of the texts, their prediction result will be get changed. And if such attack is intentionally, and nearly half of the predicted labels, they will get changed. So it indicates like such model is vulnerable. And also we find like some very typical typos and misspellings are very likely to fool this model. So this indicates like if someone really wants to, he can create such adversarial or manipulate such adversarial text very easily with low cost, but however, it will successfully evade the model's detection. And all of these evaluation results can encourage the model developers to further improve the model development and meanwhile to enhance the model robustness. And we want to point out here is that the vulnerability observed from certain settings, they can suggest the corresponding way to improve the model. For example, if we apply the action of like perturbation, and this model show vulnerability, then very likely means like the spell check component is missing or not working correctly. So it indicates like the model developer may enhance the spell check component. And if the negation such a action and cause the vulnerability, then it's very likely like during the model development, the bigram or n-gram is missed or overlooked, and it indicates like the model development can be improved in this way as well. And the second case study is like how we can utilize this evaluation process to enhance the model's robustness. And we did this based on our simulation. So we have compared an original model, which is a binary NLP classification model trained with email text. And we trained a second new model by adding generated adversarial text into the training data. Means like we expand the training data and train a new model. And if we look at the performance, the new model has a very similar performance as the original model, but the benefit is like such new model is more robust than the original model. So for example, under one setting, an original model, when it's tested with adversarial text, about 11% of the messages, their predicted label will get changed. However, for the new model, only 5% of the predicted label will get changed. And it implies that sometimes when misspelling check component is not available in the natural language model development, we can instead like just enrich the training data with additional adversarial attack. And by doing in this way, it can also help to improve the model's robustness as well. So that's everything about my today's presentation. And just to summarize here, we develop a standardized process to evaluate natural language models' robustness. And this process is automated and incorporates a lot of typical approaches and features, and can be applied over a variety of the natural language models the banks usually use. And this allows us to consistently use this procedure and the criteria to assess the natural language model's robustness. Meanwhile, we can accommodate each individual model's specific purpose and the user scenario. And that's all for today's presentation. Thank you very much.
Amazing job. That was awesome. Thank you so much for sharing with us today. I know this virtual crowd is going wild with virtual applause. All right. For the audience, it's time for you to make your way to your next session. Along the way, make sure you accept your connection request and take some time to check out our amazing exhibits. Thanks so much, and we'll see you around.
Thank you.